So I'm very pleased to welcome Lucian Precup from Adeline and the all.site search engine to his achievements there. Based in Paris, and was the very kind host of a Haystack on tour we did, I think, end of 2022,
yes,
which was great fun in Paris. And Lucian is a stalwart of the Haystack conference, has done many talks here. So we're going to hand over to him, and he's going to be talking about Apache Lucene and the journey from text indexing to artificial intelligence. Lucian.
yes, hello. So thank you for being here. It's so nice to find you again. So I have some questions for you. So yeah, I know we are also online, but for people who are here physically present, how many of you are Lucene committers in this room? Okay, so we have one person here. So yeah, thank you for everything you do. How many of you work with a Solr, Elasticsearch, OpenSearch, so with Lucene in some way? Okay, so like you're maybe three-quarters. And how many of you are like with other search technologies? Like Algolia, like Weaviate, Pinecone, or something else? Okay, so a few people, yeah, great. Thanks. Yeah, no need to introduce this more than that, but Lucene is a search technology, a very powerful search technology. And what's interesting about Lucene, what's amazing about Lucene is that it was first incubated into the Apache project in 2001, which is really, really amazing. I am not aware of another technology that has such a long lifespan. Maybe all the technologies that we are using today, half of them have less than 3 years. Technologies that we used 5 years ago are no longer used anymore. There was a time where we talked much about, for example, Hadoop or other things like that, which technology is still there, but we don't like see the same traction. And I don't talk about like front-end technologies that like come and go really quickly. So 22 year and a half and counting. And yeah, that's like so amazing. Like looking back to the life of Apache Lucene, these are some citations that I took from Twitter. By the way, Twitter uses Apache Lucene for its search, internal search. They were even committers in the beginning, and they were extensively using Apache Lucene. So yeah, Twitter didn't exist when Apache Lucene was founded, but these are tweets from 2011 and so on. And what we see are a lot of work that has been done throughout the time by the community and by the committers on performance. We see a lot of things that all of a sudden go like 100 times faster, 50 times faster, 5 times faster, any faster, in any proportion. We also see Apache Lucene finding bugs in the JVM. It's maybe the project that has found the most bugs in the JVM. And yeah, and it continues since the beginning of Twitter even. Yeah, the last one is talking about vectors, which is something that was in the hype last year and the year before. Yeah. I don't know if you know this conference. How many of you know about Berlin buzzwords in the room? Okay, great. So it's a European conference that that takes place in Berlin, and it's the reference for everything search, store, and scale, mainly in the open source world. And since quite a long time, we see each year a talk around Apache Lucene, either what's new in Apache Lucene or how many bugs Apache Lucene found this year in the JVM, or how did we test and improve the performance and so on. And I am actually ready to bet that in 2031, 30 years from 2001, we will see someone that will talk about Apache Lucene and Berlin buzzwords. So, yeah. Apache Lucene, it's actually powering a lot of technologies. We don't talk much about Apache Notch these days, but it was powered by Apache Lucene also. Apache Notch is like the technology that came right before Hadoop. We of course have Apache Solr. That's was even like merged with Apache Lucene or Lucene for some time. We have, of course, Elasticsearch, but we also have some newer technologies. MongoDB actually chose Apache Lucene to build their search capabilities. So it's like choices that were made like 2 years ago. So we are still like choosing Apache Lucene for new projects. It's not like it's a technology that's there because it has a large number of users. I didn't introduce myself, so I'm Lucian. I work with a company called Adilian, and we do everything around consulting, training. We also develop a software that's called A2, and it's built with Apache Lucene also. Charlie mentioned all.site, which is a collaborative search engine that's also built with Apache Lucene underneath. Now let's take a step back and see how we got there, how Apache Lucene managed to reinvent, not necessarily reinvent a wheel, but reinvent itself throughout the time, throughout the years. So the basis of Apache Lucene is the inverting index. I'm sure you already know about that. And I just wanted to like focus on that because this is how it started. I take here 3 documents, and the first thing that Apache Lucene does with those is the tokenization. So it extracts words. I mean, they're not really words, they are tokens, but in a simplified version, we can say that they are words. Then we keep the unique words, we sort them, and then we list them. And this is the inverted index. This is the very first version of Lucene. It's an exercise that you can give to a student at university or to a candidate that comes for a job interview, or even to ChatGPT. It will be able to write this program. So this was the first version. We have also something that's really a core functionality of Apache Lucene, which is the analysis chain. Okay, so actually these tokens are not put into the index as they are transformed through an analysis chain. So you see that we have capitals here, so we lowercase them. You can see that we have, for example, cars, which is plural, automobile, which is not, it's singular. So we can do something around stemming, for example. We can also provide synonyms. This is something that arrived later, but it's something that's available. So we can say automobile and car is the same thing, and so on. We can also like use what we call stop words, because we see that some words like to, the, of, on are actually checking all the marks. They are retrieving all the documents, so we consider them like non-relevant for the index. And we get to something like this, and this type of structure is really optimized for performance. And it's also optimized for Boolean queries. If I search, for example, for automobile, the answer is right really fast. I can go directly to the pointer to the documents that correspond to my search query. In this case, is document 1, document 2. If I search for France, I find another set of documents, which is document 2 and document 3. And then doing the intersection of these two sets is really fast. So all the Boolean queries are really fast with Apache Lucene. This is what the technology is built for. In reality, there are some other structures that are there because we also need some metadata. We also need to support phrases and stuff like that. So in reality, even the first versions were a little bit more complex than this. So yeah, we can, this syntax is still available today. It's still available in user interfaces like Kibana and Open Search dashboards. And yeah, you could do search on a field. You could do phrase search, so positions. You could do fuzzy search, approximate. You can do approximate on a phrase, and so on. Some of these were not available in the beginning. We will see about that. I talked about the text analysis. This is also something that's fundamental in Lucene, and it's the fact that we can analyze the text at index time and in the same time at query time. This is something that makes the Apache Lucene so powerful. So actually, the two transformations find themselves together in the index, and yeah. This is why it works so fast. This is an example of an auto-completion service, and we start to see where it's going. So actually, Apache Lucene calculates a lot of things at index time in order to be fast at search time. So for example, auto-completion, back in the days, it was done with wildcards. This was the way to do it. This means that we have to scan all the index. And yeah, we introduced n-grams, and this made the index a lot bigger, but that was not necessarily an issue. When it became an issue, then Lucene introduced the compressing of the index, and we finally, even with n-grams in the index, we ended up an index that has the size of the original text file, while also embarking a lot of functionality in it. So the analysis chain can be different at query time and index time, and it allows us to do plenty of interesting stuff. Okay, in this example, yeah, we have an analysis that's active. That's the same at query time, and this one is different at query time, so the functionality is slightly different. So we have a different behavior. Just to cite also Apache Solr in this talk, you have a nice interface in the Solr dashboard that actually allows you to debug what's happening with your text. And prior to this interface, we had other tools that allowed to debug what was happening into Lucene. I mentioned in the beginning there was a citation that was saying that Lucene is 100 times faster for fuzzy queries, and actually this is not only fuzzy queries. There was a big wave of changes that came into Lucene that were FSA and FSTs. And this was really a game changer. So this was the functionality, this was the structure that made fuzzy queries so much more performing. So we really had 100 times faster queries following to this. And this structure was later pushed through a lot of other functionalities of Lucene. So this goes in the same direction, like building the index with all the necessary data that's needed. For example, this graph here represents the word dogs. and it's huge, just like the n-gram earlier. And this is why it's limited to 2 characters of distance, but nevertheless, it's really a great improvement in performance to have something like 100 times faster. And it was really a game changer. Following to that, or not necessarily following to that, Apache Lucene was used a lot in e-commerce. And we soon realized that we also need numbers. Apache Lucene was a text technology. It didn't support numbers in the beginning. If you wanted to, for example, sort, like in this example, sort the prices, you really needed to use strings and to pad them with zeros in order the sort to be correct. So yeah, adding numbers was also a challenge, and it was like taken by Apache Lucene, and it was implemented really well. I'm not aware of all the details, but for example, integers are not stored in the usual manner, but they are stored like to gain space. And then we had also, coming from e-commerce in the beginning, the facets. So we needed term facets, range facets, hierarchical facets. And we realized that we have to invert the inverted index quite often to build a structure that's called field cache. And actually, this was the beginning of what we call doc values, which is actually another structure that's a columnar database that's also embedded into Apache Lucene data store. And with this came a lot of use cases, as we will see later. We even have like features related to relational databases where we could really do query time joins with Apache Lucene. There are 2 features that are really great for e-commerce, which is the nested the documents, or the document block, and the field collapsing also. That was introduced quite early in Apache Lucene. So e-commerce was driving a lot the features of Apache Lucene. And then we had maps. So all the polygon searches and all that were quite slow in the beginning because they were using integers, so numbers, which are not the best structure to store polygons and points in order to calculate, for example, that a point, a latitude, longitude is within a city, for example. We needed to like go through all the points and calculate distances and stuff like that. And then came the geo shapes and the geo bounding box query and all the stuff around that, which made actually Lucene become the most used and maybe the best spatial database. And with that, this brings us to all the use cases that you might know around monitoring and observability, and use cases that today make maybe 18, if not 90% of use cases of Elasticsearch, and maybe also OpenSearch. So like 80% of use cases of Apache Lucene. And we all know where it ended. I mean, it's not ended yet, but it continued, and it's actually taken like another direction from there. And then we had vectors that came on. We said, okay, but I need I'm sorry that you cannot see the links here on the screen, but I cite my sources. So this comes from Elastic. They do some nice animations there. So we needed semantic, we needed vectors. We had a paradigm shift with all the vector search there, and we introduced vectors. So I will go quite quickly around this because you've already seen the presentation this morning that was presented. So the presentation about hybrid search. So what are vectors? they are actually a vector space representation of text, but it also introduces multimodality. So you can also use image search and audio search because you just need to use a machine learning model that knows to construct the same structure out of text, audio, and video, and you can get what we call a vector. So for those of you that do not know how it works, the vectorization here. So here's a simple example of a three-dimensional vector. It's just 3 dimensions. You have size, friendliness, and intelligence. And we try to categorize any object whatsoever, an image, and a text, an audio file whatsoever, compared to these axes. So we have 3 here. In reality, vectors have thousands of axes, or at least hundreds. So yeah, for example, a cat would rate in size 0.25 compared to an elephant, which is 0.90, 90, and so on. And then all the documents in our index are placed into a vector space. And when we come with a new document, which is our query, we will just find the nearest neighbors. So as I said, this allowed to do multimodal search, and this is how the vector search is working. We take the documents in the input, we construct a vector representation of these documents, and then we do the same thing with the query. We have to use the same model or a model that knows to treat the query as a query, and we compare then the vectors of the query with the vectors that are available in the index. At first, we had KNN, which is kind of a brute force approach, and then we introduced approximate KNN, and which allowed a faster faster approach to vector search. And it continued. We had KNN with filters, which is also a feature. And yeah, this is the first step to hybrid search. And as you saw in the talk this morning, for those that followed it, yeah, if we need vector search, we need hybrid search. And if we need hybrid search, Lucian is a good choice. We also have support for sparse vectors, which is a different structure that is like more easy to maintain, and which is compatible to the inverted index that Apache already has. So this is an ability that we do not see often. So we can support both of them, both dense and sparse, and which is great. So this is an example of term expansion, which is used for sparse vectors. So it's actually similar to what you saw in the fuzzy query, where we construct a graph of all the possible combinations of a term. Yeah, so we survived geo search, columnar databases, vector search. And then we had ChatGPT, which was actually kind of a game changer. How many of you are using ChatGPT as a search engine instead of a search engine? You go to ChatGPT to ask a question instead of going to Google. Okay, so you are quite a lot. So was this the end of search engines? Was this the end of Apache Lucene also as a search engine? There was a lot of debate when it started. We actually moved from this, which was like the search engine that was putting everything on relevance and personalization, everything on doing what's in my, I mean, doing what's capable of doing to give you the best result. And we moved to this actually. I don't know how many of you are using Bing. Maybe you're not many because you switch from Google to ChatGPT directly. But this is the new Bing. So it's actually no longer like I'm feeling lucky like this with just one search result, which supposedly is the one that contains my answer. It's actually a chatbot powered by a technology that's called Copilot, and it's based on ChatGPT. Yeah, so just taking a step back, we kind of saw that coming. Charlie was mentioning Haystack on Tour Paris. We had this meeting, this tour, this conference in November 2022. It was just 1 week before ChatGPT was released. We didn't know that it was coming. And when the audience asked, so what's the next for what's the future of search engines? We kind of saw that the future is somewhere around question answering, because we said that search engines give you results, a list of results, and it's up to you to click on the one that's the most relevant for you in the first page, maybe, or maybe in the second page if you go there. And then open that result and read it, summarize it, understand it, and search the response you're looking for in that document. So when you actually when you're using a search engine, you're not looking for a list of results, a list of possible links to the answer to your query. You're actually looking for an answer. And Google understood that and introduced this question answering feature quite early, right after they invented the transformers. The transformers were something that was invented by Google and allowed ChatGPT to pop up later on. And yeah, you had this thing coming, and then you had also Bing that was doing things differently, but kind of better, I think, because if you notice here, you have the same answer, but you have that note there according to 5 sources. So instead of like doing like Google, like take the one that I'm feeling lucky, I'm taking just the first result and summarize it and give you the answer. I will take like 5 results, compare them, like find the best one, and so on. Okay, so moving back to LLMs and ChatGPT, actually we realized very quickly that there are 2 problems with that. One is that we have no knowledge into a specific area. We have a lot of knowledge globally, but not something specific, and we also don't have real-time knowledge. And the second problem is hallucinations. These models are trained to produce words no matter what. And yeah, they give answers, not necessarily proven sources. And that's the first, that's the second problem. Yeah, so I guess you're all aware of that. So this is the no real-time knowledge. If you ask ChatGPT, even GPT-4, what happened in 2022. Yeah, I don't know if you know this date. This is something that's important for the British guys. Yeah, ChatGPT doesn't have the answer. And also, if you're asking something very specific on a specific domain, that's maybe a domain that you know, ChatGPT will not be able to answer, because yeah, maybe this domain is not that well represented on the internet. And then you have hallucinations. As I said, LLMs will try to answer no matter what. So you can ask like any question, and you can even have like questions that really do not have an answer, or questions that are wrong in the first place. But you will have an answer that looks convincing, and it's actually not the right one. And then you have also the problem that as it is, an LLM will not be able to tell you where it has found that answer. So which is a problem, because you don't know if it's a fake news or if it's something that should be taken into account. And we get on RAG, retrieval augmented generations. So you have seen already a lot of talks around these subjects. There are also a lot of talks tomorrow and this afternoon on this subject. And this is actually the solution to the problems LLMs have, and also the, let's say, the future of Apache Lucene, because as you can see, you need a vector database in this solution. You actually have a user query that will not go to the LLM directly. It will go to a search engine first, and then go to the LLM that receives the question and also a context. And the context contains things that are hopefully relevant for the right response in the end. I just wanted to mention also the keynote that we had last year, which was really insightful. And we were actually talking about ChatGPT, and it was Trey Granger that presented a prompt that allowed ChatGPT to cite its sources, which was something that was not doing by default. And back then, RAG and retrieval augmented generation didn't even have a name. So I will say, yeah, thanks to Haystack and to, I mean, we are really discussing here things that are in advance to our domain. And yeah, this is really great. As I said, this was RAG, but it was not called RAG back then. Yeah, so coming back to search engines, of course, you have the question answering, and quite soon, if you see the thing on the right there, Bing introduced ChatGPT directly into the search engine. So, I mean, just to explain how much of a revolution that was and that is actually. So the fact that we are moving away from search engines to LLMs, it's really something that's happening. So the first versions of Bing were like kind of bad because they gave responses, and the LLM was not really, let's say, it could do like answer wrong to the user and all that. And actually, the prompt that Bing was using was improved, and it makes it's a prompt that has like 3 pages of instructions there, and so yeah, Bing tells it was called Sydney. Bing tells ChatGPT to behave correctly, to not to use like not to be mean and all that. And yeah, so this prompt here actually resembles a lot to the one that Trey Granger showed, which is a lot smaller, but it does the job. So as you can see here, you have the sources that are cited. So the LLM gives a response, but also it's documented with search results, actually. These are search results just represented in a different manner. Okay, so yeah, we arrived to something like this. This is the new Bing. You ask a question, you get the answer. You also have links to the source of the of that answer. And actually, this is the same thing that GPT-4 implemented when it goes to the internet and retrieves data, if you tell it to do so. Okay, so where does Apache Lucene stand? So you have the RAG pattern. And yeah, I placed Apache Lucene here on top of your business data, because if you look at the internet, your business data is not on the internet. Your Slack channels are not on the internet. Your wiki is not on the internet. So you really need a technology like Apache Lucene to index something that the internet cannot access, something that Bing will not have access to. Yeah, even if you're using, for example, Microsoft for Enterprise, you will always have systems that are not taking into account, for example, if you have Atlassian in addition to Microsoft, for example, you will still need something in between to index all those data sources and to build your own RAG system, as we also saw in some of the conferences here. Okay, so I also have yes, we don't have much time. I also have like a small demo. It's not much, but we don't have much time. I just want to point you to this presentation that my colleagues will do at OpenSearch conference next month, which will actually like go through all the details of how you can implement a RAG system with Apache Lucene from A to Z. I will try to maybe bring up a demo, a quick demo. We have 3 minutes left on Elasticsearch this time, just to give credit to everyone. Yeah, so just before we leave, let me just switch to this short demo. I will go directly to the end of the demo. Can we see it? Yeah, I'm sorry. Okay, so here it is. Okay, so this is like a small assistant that was built on top of these data that are here. So actually, yeah, in this demo we go through all the vector search and machine learning and implementing a RAG system. So we have all the talks that are available on the Haystack homepage. I just wanted to show you how many documents we have here. So we have 20 talks here. And yeah, they are all here. And just on top of that, I will show you, if we have time, the details. If not, we have also the lightning talks there afterwards. So when you ask questions like this, for example, you get search results, but they are actually presented in a conversational manner. Okay, so how it goes, you need, as we saw in the presentation, you need to, I'll go directly to the vector one demo. Okay, so this is the indexing part. This is the pipeline that allows my data to get vectorized. This is the target field, which is also already configured with the mapping, a specific mapping. This is the model ID that I downloaded from Hugging Face. And then I reindex my data to the target index. And then I can ask questions like this one, for example, which is just a vector query. I also have examples of hybrid queries. And yeah, for example, here I search for artificial intelligence, and I have things that are related with that. Not necessarily, they not necessarily mentioned artificial intelligence as keywords. They mentioned, for example, AI or something within those lines, and you have the answer. Okay, so yeah, this is a talk that will be here in this room tomorrow. So yeah, that's all for me. And yeah, it's loading. It's just yeah, this is the thank you screen. So thanks.
Thank you, Lucian. Okay, so I'm going to kick off with a question from our online audience. Teo has a question. And this is quite a general question, but what are some best practices for using both vector and keyword-based retrieval at the same time?
Yes, I wouldn't say that there are best practices. If you saw the talk that that was here this morning about hybrid search, exactly, it was actually mentioning, it was really interesting. So take a look at the video when it's out. It was actually mentioning the use cases that you have, and depending on the use cases that you have, you will implement the right hybrid search. But the bottom line is that hybrid search is almost every time useful. So we difficultly can find use cases where just pure vector search is enough.
Okay, thank you. Any questions from the floor? A question right at the back. Okay.
Thank you for the talk. It's very nice to see how Lucian is evolving. You mentioned some user experience, and I would even say user interface considerations in the difference between how Bing presents results when you do retrieval augmented, but want to show the sources and let the users have their own understanding. Can you speak a bit about how Lucian implementations have evolved in terms of user experience and user interfaces? And do you see this changing over the next days or next years as we see user interfaces having an impact on how people can leverage RAG for actual actions?
Yeah, thanks for the question. So actually, Apache Lucene is a low-level library that provides all the tools for you to implement on top of it. And that goes also for Solr, Elasticsearch, OpenSearch that are built on top of on top of Apache Lucene. They are not actually providing user interfaces. But that being said, you can let me just go back. You can, so with this pattern here, you see that Apache Lucene needs to be there to provide you with the vector search and mostly with hybrid search also, most important. And this allows you to have interfaces like this, for example, where you give the answer, but you also give links to the data that contains the information that provided the answer. So the interface, the user interface is actually up to you, up to your application. You can implement it like this or like this, for example. So it's something that's up to every application. But Apache Lucene, we just provide the tool, so specifically the hybrid search.
Just like to add to that. I mean, the interesting thing is, I mean, this reminds me of the fact we did actually plan a UX for Search and AI workshop for Haystack, and sadly, unfortunately, our workshop tutor had to pull out due to some family health issues, so we had to cancel the workshop. But it's something we're looking to quite a lot at OSC, and I'm not sure we all give enough consideration to the user experience when we're building search applications. I suspect a lot of us here are back-end people and not great, you know, not so focused on that area. But I think it's something we need to look at more, because we are seeing radical changes in how people are using search-backed applications. It's moving away from 10 blue links. And I think this is something we need to take more account of. So yeah, maybe there will be more on that over the next year. Do we have any other questions for Lucian?
And the new search engines kind of look like this now, so it's more like a chatbot than or an assistant or a co-pilot than what we used to call a search engine before.
Okay, well, we have no more questions from online, so please put your hands together for Lucian.
Thank you.